First thing we should probably talk about is the fact how to pronounce it. I have seen it spelt a whole bunch of different ways to start with. One way it's spelt is like what's up here, La Hospital. I've also seen it spelt without the S, so it'd be like L'Hôpital. And I've also seen it with the little caret above the O, which I'm assuming is like a French symbol. I don't know. I know nothing about French language. Is anybody hearing French? No. Oh. Okay. Well, either way, it's L'Hôpital. And so he was the one who discovered this feature, and so they named it after him. So it's L'Hôpital's rule. Probably the weirdest part is that we're doing a section with limits near the end of derivatives. And this section is a strange one to fit in. This actually used to be in Calc 2 to make it convenient, because Calc 2, they usually redo Calc 1 at the beginning of the year and then kind of teach new topics after that. L'Hôpital's rule uses derivatives to find answers of limits. And that's why it's kind of an awkward one to fit in anywhere, because we learned limits to teach you about derivatives. But then this rule, you have to know derivatives to be able to find the answer. So there's never really a good spot to put it. What is convenient is that L'Hôpital's rule is specifically for solving limits that are indeterminate. Basically those two. There are a lot of other ones over here, but these are by far the most common indeterminates we run into. All these other indeterminates over here could be rewritten as one of these first two. So maybe I'll just write down one of the common ones you guys were used to seeing. So the limit as x approaches 0 of sine of x over x. So this was one of the two special trig ones, right? And we didn't have any way of finding this answer, because you can't factor it, you can't do a square root, like you can't rationalize it. There's nothing for us to do to it to like get an answer that works. And even when we graph it, you can't really tell on the graph, because the graph goes up and down and squiggles a lot. So this one, theoretically, we skipped it, but this one is proven by the squeeze theorem. And we knew that the answer was 0. Like, you were just basically told the answer was 0. So anytime, wait, not 0, 1. That was a great start. Anytime we were using this one, you used that fact to find answers. Well, I'm going to start off by showing you notation that we're not allowed to use. And that's a whole nother story that I don't want to talk about till Monday. So today I just want to teach you the thing. Monday we'll worry more about how to write it. The reason we couldn't do this one is because if you plug in 0, sine of 0 is 0, and 0 is 0. So it was indeterminate, and it didn't give us an answer. What L'Hôpital's rule is going to do is you are going to be allowed to take the derivative of the top and the derivative of the bottom, and that's an equivalent limit. So if I take the derivative of sine of x, I'd get cosine of x. If I take the derivative of x, I get 1. So L'Hopital's rule says that these two limits are equal or equivalent. And it only works when your original one is indeterminate. And when we take the derivative, well, now I can plug 0 in. Cosine of 0 is 1 over 1. And the answer is 1. Yeah?
Why does it only work if it's indeterminate?
Great question. Honestly, I've never heard. I'm assuming the real proof of this rule is lots of pages long, and I've never actually seen it. L'Hopital's rule wasn't even something that was taught when I was in school. So it wasn't even part of Calc 1 till 3 years ago. No, 4 years ago, excuse me, when they updated the test. And it's not a difficult topic, but it's very possible questions like that might be why it wasn't. I don't know. Yeah, I've never actually seen anything about it.
Is it new? Or like, why
Nope.
wasn't it introduced into the curriculum?
No idea. I know it, so AP wasn't around when I was in school. So AP itself, I don't know. I mean, AP was around, but just not in my area. It was part of Calc 2 because it used to be considered a more difficult topic. And I'm going to say the reason it was considered more difficult was because of the rest of these indeterminates. So the rest of these indeterminates, if you get them, you have to basically alter them and change them so that it's a fraction, like 0 over 0 or infinity over infinity. That's my assumption. As in terms of the actual problems, they're not hard to do. I don't want to worry you by pointing to all these other indeterminates. I have yet to have seen one that is of this style. I have only seen these two been presented. Not that these are untouchable, like not that they can't give you these. I just haven't seen one of those yet. So I'm kind of going under the assumption that they're still going to focus on 0 over 0 or infinity over infinity. And that's basically all of your homework as well. Like they're all set up like that. But it's just kind of an odd topic because you have to use an idea that you don't know yet when you're learning limits. Like limits are to teach you about derivatives, and you have to use derivatives to find the answer. So it's kind of a strange, like it's definitely a unique situation like that. Okay. Lots of stuff. Lots of words. Maybe well, what the heck? I might as well just talk about it today. It'll take a while. So, the notation I used right here is how I was taught L'Hopital's rule in school, like in college, and how we taught all students to use 4 years ago when they decided to put it on A/B test. And apparently, this is 100% incorrect. Oh, sorry, I erased it. I erased it out of fear of keeping it there. You're not allowed to write equals 0 over 0. And so it's definitely a technicality. And AP is making it a real big point of emphasis that you are not allowed to write that. So they literally made every AP Calc teacher 3 years ago go to a workshop on L'Hopital's rule because everybody was writing it incorrectly according to them. And it really doesn't matter which way you think is right or wrong, but the way that they're going to grade the questions, this would be given no credit. So AP is making it a big deal that if you write equals 0 over 0 or equals infinity over infinity, they will not give you credit for the problem at all. Because to them, it is a very important idea that you understand you can't equal an indeterminate. Because there's no actual answer to an indeterminate, you can't equal it. So we have to write it a special way. And that's what's super annoying, and that's why this section takes longer. The problems themselves, you're not going to have difficulty doing the work. It's a pain in the butt to write the answers to these questions. It's just how it goes. And that's what kind of is on this next page. So, on page 2 of your notes, where it says proper notation and protocol, if you figure out a limit is going to be indeterminate, you have to write that separately. And then once you see that it's indeterminate, you have to say it's indeterminate. And then you have to state that you're using L'Hopital's rule. And then you can get an answer. I'm not the one that's grading these, so I can't have an opinion on it. Just kind of letting you know that this is, for whatever reason, what they're looking for. So that's how I'll teach it to you. Because I don't want you to get in the habit, like me, I did it for so many years with incorrect notation for them that it's actually really hard for me to do these because I'm just so used to writing equals 0 over 0, equals derivative. That's how I was taught it. So if we plug 5 in, we're going to find that we have 50 minus 45 minus 5, which is 0, over 5 minus 5, which is 0. So the way that you're going to have to write this is you have to say the limit as x approaches 5 of 2x squared minus 9x minus 5 equals 0. And then you have to say the limit as x approaches 5 of x minus 5 equals 0. So it's okay to write equals 0 because 0 is a number. But you're not allowed to write equals 0 over 0. So this is kind of the workaround. You say that the top has an answer of 0, the bottom has an answer of 0, and then this is indeterminate form. And I am not going to write L'Hopital's every single time. Oh, what the heck. Although, it is, I don't know why, but I find it fun to write La Hospital. Because it sounds kind of weird. But you can say by L'Hopital's, and I will just do L apostrophe H. So by L'Hopital's, the limit as x approaches 5 of 2x squared minus 9x minus 5 over x minus 5 is equal to the limit as x approaches 5 of the derivatives. So 4x minus 9 over x, over 1. So this is kind of what they consider correct notation. And you can number these steps if you want. You can bullet point them. It's just, that part doesn't really matter. That's just kind of up to you how you like to write steps. And then now we've got it to a point where we can plug 5 in. So equals 4 times 5 minus 9 over 1. 20 minus 9, which is 11. Go ahead and ask anything you may want to ask. Yeah,
How did you get 45 minus 9? Is it 21?
4 times 5. On my computer, you can see it times easy, but it's showing up blurred here. 4, I plugged 5 in place of x, so 20 minus 9. There we go. I'll put a parentheses. That should show up better. I wouldn't put it past me to write 45 though. In terms of like following along with what you're supposed to do, are you guys okay with that? I mean, like, I don't know what you'd want to ask from this.
So then would you circle 11 as your final answer?
Yep. Yeah, because I've got equal signs going throughout, so I wouldn't necessarily have to rewrite limit equals this. Now, I didn't even try, but I'm guessing this factor's up on top. So this very possibly is one of the questions we would have done in Unit 1, and we would have done it by factoring. But like I said, I didn't even try. We were just going over how to do it with L'Hopital's. So I'm assuming this factors into 2x plus 1, x minus 5. 2x squared minus 10x plus, yep, that's what I thought. So the original way we would have done it, is cancel the x minus 5, plug 5 into 2x plus 1. So we are purposely practicing L'Hopital's on easier questions because the derivative was a lot easier. But a lot of these questions will have multiple ways to be done. And on multiple choice. It doesn't matter how you write or do anything. I'm hoping you guys understand that me talking about this, the only time this is going to matter is on a free response question. Because on a free response question, they grade what you write out. On multiple choice, they do not look at work or anything. They just look at your answer only. So if you're doing a multiple choice question and you realize it's L'Hopital's, you can just sit there and do scratch work really fast to get the answer. And traditionally, that's going to be faster for you than factoring. Even though factoring's easy, you guys probably are really comfortable with doing derivatives by now, and it's probably decently quick at it. So there'll be more than one way to solve a bunch of these. But the whole goal here is to practice L'Hopital's. Like this next one. This one I guarantee could be done by rationalizing, but we're not going to. Do you guys think you could try this one already on your own? Okay, see if you can follow the notation that we used up above. square root of 4 minus x is going to be 1/2. 4 minus x to the negative 1/2.
I just worked this last. How far are you?
I mean, the derivative is most likely the slowest part of the problem, other than writing everything out. Should I make that bigger? Oh, that's not bigger at all. Say it again. 4 minus negative 5. That's why I was just wondering if I should zoom in, but if that's all further, I can zoom in. When I'm trying to fit a lot of info up there, some details might be hard to see.
So, for writing it out, could you instead say for the derivative like -1 over 2 root x, or root 4 minus x, or is the,
That's fine.
are they gonna allow, because I know that they don't really like fractions over fractions.
Oh. What's the best way to say this? On free response, you're allowed to write it however you want. On multiple choice, you have to match up with the answers that's there. So a lot of times when we go over, they don't like fractions and fractions and stuff like that. That's only because you're trying to match up a multiple choice answer. In free response, you can leave however bad the question looks that you want. So that's absolutely okay to write just your own preference. I just wrote it that way because it felt neater. But if you like writing roots in the denominators, go for it.
Is there a difference between 9 to the 1/2 and 9 to the negative 1/2?
Yes. So 9 to the 1/2 would mean square root of 9. 9 to the negative 1/2 would mean 1 over square root of 9. So that the negative moves to the other part of the fraction.
Thank you.
Yeah. Yeah.
Where'd you get that 1/2 from, or -1?
Derivative of 4 minus x. So that's like the du. Or chain rule, however you want to say it. So what you guys are going to probably find, this topic is similar to the topic we just got done doing, in that it's an easy idea to understand, but there's just so many details that there's a lot of different examples to go over. So there's not necessarily anything more for me to teach, other than there's just a lot of problems for you guys to try. And I don't mind, I was pretty much planning on Monday on doing a whole bunch more examples with you. I mean, I don't know if you need to see them or not, but that's kind of what I thought I would do with you guys. They're all going to be set up the same way. It's just getting into the habit of writing it a certain way and getting comfortable with doing certain things. So that's why all Monday and probably half of Tuesday we can dedicate to this section, even though there's nothing more for me to teach. This is the whole idea behind L'Hopital's. It'll just be you getting used to and comfortable using them, working with them. So you're welcome to try some over the weekend if you want. I guess it probably just depends on your own schedule. If you're going to be busy next week, maybe you'd want to get stuff done this weekend. If you're busy this weekend, you can hold off till next week if you need to. Just kind of plan your own schedule accordingly.